When we use neuroscience in the workplace, a common concern is that we're somehow crossing this invisible, sacred boundary, right? It feels sci-fi. Welcome to this explainer. Today we're unpacking a really fascinating and, honestly, absolutely crucial topic: the ethical guidelines for using functional near-infrared spectroscopy, or fNIRS, in high-stakes, hierarchical environments, like the military. We're going to dive strictly into the source documentation to understand exactly how we can guarantee voluntary participation, lock down data privacy, and completely bust those lingering, mind-reading fears. So let's get right into it.
To practice what we preach, consider this our very own version of informed consent for you. Here's the roadmap for what we're covering today. We'll kick things off with the mind-reading misconception. Then we'll move into the international ethical baselines guiding this research. After that, we'll navigate the complexities of voluntary consent within strict hierarchies, look into privacy and data access, and finally, we'll shift our whole perspective to evaluating tasks rather than people.
All right, Section 1, the mind-reading misconception.
Okay, so let's break down this definition. What exactly is fNIRS? The documentation describes it as a physiological measure of changes in oxygenated and deoxygenated blood in superficial cortical areas, mostly the prefrontal cortex. Now, I know that sounds incredibly technical, but let's demystify it a bit. It simply shows whether a specific area of the brain is physically working harder during a task. Think of it as an indicator of cognitive load. In fact, the source compares it to something you're probably wearing right now, a smartwatch. You know how your smartwatch uses light sensors to check your heart rate or oxygen levels to see how hard you're physically working out? Well, fNIRS does the exact same thing, but uses light to give a physiological read on your mental exertion. It's just a sensor, tracking effort, like how your heart rate spikes when your boss pings you out of nowhere. It's really nothing more than that.
So there's obviously this huge, stark contrast between the myth of some invasive surveillance tool and the actual reality of the technology. Look, fNIRS does not give anyone access to your deep, dark thoughts, your intentions, your memories, or your political beliefs. It's definitely not a sci-fi crystal ball showing what you're thinking. The reality, it just measures cognitive load, task demand, and physiological effort. Basically, it just adds a layer of data to tell us, hey, this person's brain was working a lot harder during this specific part of the task. It's a tool for understanding workload. It is absolutely not a window into your soul.
Moving on to Section 2, international ethical baselines.
Now, the standard ethical baselines we have for human subject research are incredibly robust. Our source anchors the discussion in 3 foundational texts. First, the Declaration of Helsinki, which mandates that participation has to be entirely voluntary and based on free informed consent. Then the CIOM's guidelines, drafted with the World Health Organization, which really emphasize protecting vulnerable or dependent groups. And finally, the Belmont Report, which boils everything down into 3 core principles: respect for persons, beneficence, which basically means doing good and doing no harm, and justice. So what's the big takeaway here? Informed consent isn't just a piece of paper you quickly sign and forget about. It's a continuous process built on respect. Participants have to be fully informed, they need the freedom to say no without any negative blowback, and they can withdraw whenever they want.
But that brings us to a really massive ethical conflict. Honestly, it's the real elephant in the room for this entire explainer. Is participation truly voluntary if you're measuring it inside a strict, hierarchical organization like the military? Just think about it. If your whole unit or crew is taking part, an individual is going to feel an immense amount of pressure to just go along with it, even if, officially, it's voluntary.
Which leads us perfectly into Section 3, voluntary consent in hierarchies.
In the ethical literature, this exact phenomenon is recognized as perceived coercion or indirect pressure. It's that nagging worry in the back of your mind that saying no might hurt your reputation, ruin your evaluations, or even stall your career. The source document insists we absolutely cannot just brush this aside. We have to acknowledge it head-on and build rock-solid procedural safeguards. So here's the necessary neutral consent procedure they lay out. Step 1, the invitation to participate has to happen independently, completely outside the direct chain of command, like directly from the researcher. Step 2, the decision to participate, 100% private. Step 3, the command line is completely blocked from knowing who is or isn't participating. And Step 4, absolutely no public declarations of refusal. So if a measurement happens during a big training day, there has to be an alternative, like participating in the drill without the sensors, so nobody sticks out like a sore thumb. This whole process completely insulates individuals from peer pressure and command influence.
All right, Section 4, privacy and data access.
Let's talk logistics, because data protection requires some serious procedural firewalls. Under these guidelines, the organization cannot, under any circumstances, have unlimited access to individual brain data. Here are the hard rules. Individual raw data stays securely locked down with the researchers. It is never, ever shared with supervisors. The organization only gets aggregated, anonymized, or task-level reports. There is 0 individual profiles handed over to leadership. And lastly, participants hold the explicit right to withdraw at any time, which means their data gets completely scrubbed from any further analysis. Think about it. If leadership could just request an individual's mental workload profile, we'd have an instant ethical crisis on our hands. These firewalls guarantee that just cannot happen.
And that perfectly highlights the strict boundaries of this technology. The prohibited uses are crystal clear here. fNIRS is emphatically not a medical or diagnostic tool. You cannot use it to diagnose ADHD, burnout, or PTSD. And it is strictly forbidden for personnel selection. You can't use it to decide who gets a promotion. The approved uses are entirely operational. We're talking about analyzing mental workload during a specific task, evaluating how effective a training moment was, and assessing human-machine interfaces. It is purely an operational tool for looking at the workload. That's it.
Section 5. Evaluating tasks, not people.
The military already evaluates its personnel constantly, right? Through observation, simulator scores, physical tests, you name it. But fNIRS shifts the ethical framing entirely. Traditional evaluation usually asks, is this specific soldier performing poorly? Do they have what it takes? But with fNIRS, the focus shifts away from the person and onto the system. We start asking, which specific parts of this task, this training, or this equipment are causing an unnecessary cognitive burden? It takes the blame off the individual's shoulders and points the magnifying glass directly at systemic design. The true focus becomes safety and making the system better, not passing judgment on the individual.
Let's look at how this builds a much more complete picture than just traditional observation. Picture an instructor standing there with a clipboard. They see a trainee make a mistake, but they really don't know why. Now, if someone's performance is good and their cognitive load is low, they've automated the task. They're an expert. But what if their performance is good, yet their cognitive load is sky high? To the instructor with the clipboard, they look totally fine. But fNIRS reveals they are barely hanging on right on the brink of overload. If the situation gets even slightly more complex, they're going to crash. What if performance is poor and load is high? They're trying really hard, giving it their all, but they just need more training. And poor performance with low load? Well, that points to low engagement, or maybe they're just totally confused. fNIRS reveals these hidden vulnerabilities so we can actually step in and offer the exact right support.
Ultimately, the source document argues something really profound. fNIRS doesn't just come with ethical risks we need to manage, it actually offers massive ethical benefits. When we use it correctly, fNIRS actively protects personnel. By making cognitive overload an objective, visible metric, it stops us from just punishing people for bad outcomes. Instead, it forces organizations to take a hard look at how they design tasks and how they train their teams. It absolutely champions human-centric safety by catching systemic issues long before they cause real-world operational failures.
Which leaves us with this final, incredibly powerful thought from the source text. We spend so much time wringing our hands worrying about the ethics of using technology to measure cognitive load. But if a poorly designed interface or a really inadequate training program is causing hidden mental overload that could ultimately compromise the safety and the very lives of the people operating it, isn't it actually unethical not to measure it? It's a truly fascinating perspective on how workplace neuroscience, when it's bound by strict, unwavering ethical rules, can actually be the ultimate tool for human protection. Thank you so much for joining me on this explainer, and hey, keep questioning the systems around you.